Good morning. So today you're going to learn about graphing, and the notes that I'm going to give you here are based on your book, which you were supposed to have read for last night's homework. So hopefully nothing here is completely new. I'm thinking that at some point in middle school or maybe even in biology last year, you learned some of these things as well, but I'm going to review some vocab to begin with. All right, so first of all, when do you use a graph and why do you use a graph? So here are 3 reasons that your book gives you. Number 1 is to show relationships between variables, which is really our big thing that we do with this. To display data collected from experiments, so it's just a visual representation of your data. And then sometimes we will even use your graph to come up with the mathematical equation. You're not doing that third use today, but you will be showing relationships and you will be displaying that data. So there are 2 kinds of variables when you're doing an experiment. The first one is called an independent variable, and the second one is called a dependent variable. You need to know the difference between the 2 so that if I gave you an experiment, you could identify which was which. So let's talk about each one. The independent variable. This is the one that you, as the experimenter, have direct control over. This is the one you, as the experimenter, will change. So the way that I remember this is that when I am doing an experiment, I am the experimenter, and I change the independent variable, which starts with an I. Okay, so the one that I change is the independent variable. Okay, so let's do this example. You want to see if eating cake while you study improves your grade in chemistry. So if you're doing this experiment, you're going to control how much cake you eat. So in this experiment, how much cake you eat while you study would be your independent variable. The other variable is called a dependent variable. So this one sounds a little confusing, but I think that you will get it once I show you an example. This is the one that changes because of what you did to the other variable. This is the one that changes as a result of the other variable. And the experiment is going to measure this change. For example, same example, you want to see if eating cake while you study improves your grade in chemistry, you would control how much cake you eat. So in this experiment, I am the experimenter and I'm going to control how much cake I eat. Because I eat however much cake, my grade in chemistry is going to change. That improvement is my dependent variable. So I specifically am controlling how much cake I eat, and I'm expecting that to make a change in my chemistry grade. That change is going to be the dependent variable. All right, so you try this one. I need to dissolve some ibuprofen tablets in water. I want to see if crushing them speeds up the time it takes to dissolve. In this experiment, the independent variable is because. In this experiment, the dependent variable is because. Okay, so pause this video and jot down an answer so that you're committing to an answer, and then we'll talk about it. So hit pause and then take the time to answer this question. You can just write on your screen. So here are my answers. The thing that you are actually controlling if you're the experimenter is if the pills are crushed or not. Because you crush them, you're expecting the dissolving time to decrease. So in this experiment, the independent variable is crushing the ibuprofen tablet because this is what the experimenter controls, whether or not the tablet is crushed. In this experiment, the dependent variable is the time it takes to dissolve the ibuprofen tablet because this is what changes and is measured as a result of the change the experimenter did. if you're still confused about this, when I will be back on Thursday. Come and visit me during tutorials or ask me a specific question during class. But you need to be able to tell the difference between an independent and a dependent variable. Okay? Because we're going to take this information and we're going to put it on a graph. So when you're graphing, you're going to put the stuff on a graph based on which variable it is. So this is why you actually need to know which one's which, otherwise you'll get your axes switched. So the independent variable goes on the x-axis, always. The dependent variable goes on the y-axis, always. Let me fix that real quick. Okay, so remember, when you're doing a graph, you have to label the axes with a measurement and units. You have to have consistent increments on the graph. So you know how on the side of the graph you would write down your numbers for like what each block stands for? So you wouldn't count, like start at 0 and go 0, 2, 4, 6, 8, 10, and then all of a sudden go 10, 15, 20, 25, and then all of a sudden go 35, 45, 55. If you're going to count off by twos, you have to go by twos all the way to the top. If you're going to count off by fives, then you go all fives all the way to the top. So you can't change in the middle. So that's what consistent increments mean. I know that some of you have graphed before and you break the axis so that you can like have a gap in your numbers, and we do not do that in chemistry. So if you don't know what I'm talking about, that's fine. We don't do it, so you don't care. But if you do know what I'm talking about, don't do it in chemistry. Okay? And then the third one is to use up as much space as you can on the graph. So if your first value starts at 100, there is absolutely no reason why you're starting your graph, your axes, on 0. If your numbers end at 20, then there's no reason why your axis goes all the way to 100. So you get to control what the starting point is and what the ending point is on each axis. And you want to choose numbers that let you use as much space as possible. Okay, so let's look at some examples. So here's my first one, graph A. So here are some things that you have to include on your chart. On the bottom, they have the years that they measured. So if this were your graph of data for the 4 years, 1993 through 1996, there would be no reason why your x-axis goes all the way to 2016. Okay, so you choose your axis based on what you need to show on your graph. There's no reason to, if your data starts in 1993, there's no reason to have 1982 on this graph. So if you notice, they started on year 1992, ended on year 1997. Okay, so that's your x-axis. That's the independent variable. The dependent variable goes on the y-axis, and for this one, it's millions of people who switched, because this is, the title says customers who switched from AT&T to MCI. Okay, you're going to see that the numbers are on both sides of this graph. We don't do that. We only label on the left side. Okay, and then again, do you see how this graph goes from 2 to 8? They don't start it at 0. They don't go all the way to 22. They use the graph to show to limit your range on that axis so that your graph fills up the page. So if you look at that graph, that red line takes up a lot of space on the graph, and that's exactly how you want it. I used to tell my kids, if you only want to use half of the graph paper I use, then expect to only earn half of the points. Okay, here's another example. So this one's missing something. Do you see what it's missing? This one doesn't have a title. So maybe for this one, your title would be, so this must be like acceleration because it's going faster over a certain amount of time. So it could be how fast I go after a certain amount of time is elapsed. Could be my title. How fast I can go after a certain amount of time elapses. Okay, so in this one, my independent variable is time because it's on the y-axis. I'm sorry. My independent variable is x because it's on the x-axis. My dependent variable is on the y-axis, so that's speed. So if you notice the way that they labeled this, they gave the measurement, which is time or speed, and then in parentheses, they put the units. we do this in chemistry, so you want to make sure that you do that as well. If you notice on this one, they connected all the dots, and so it makes this pretty curve. So in your book on page 28, it talks about drawing the curve. That's what this is. Okay, drawing the curve. What else do I want to show you on this one? This one, they actually start the graph at 0 because their numbers go from 0 to 6. So the last data point is at time 6 seconds. So you notice the graph doesn't go all the way to 15 seconds. It doesn't even go to 10 seconds. It stops and only uses the space for what it needed to be. Okay? All right, this one, a little blurry, my fault. I should have probably picked a different graph. But, so you can see that the axes are labeled. I'm not even going to try to make sense of those numbers. My old people eyes can't see what that says anyways. But what I wanted to show you here is this is what's called a best fit line, which you also learned about on page 28. So you put all your dots on there, and then you draw what you think is the best fit line. We'll talk more about best fit line. You're actually going to have to draw a best fit line today, but we'll talk more about that later. I will tell you that as you draw this line, you just want to draw a line where you think, or that you think most of the dots are around. So if you notice on this one, it doesn't even intersect any of those dots. And that's actually okay. Some people might have the line a little bit higher or a little bit steeper. And that's what is, when you draw a best fit line, you may not match anybody else in the room. But you're going to commit to your best fit line, and for you, you're going to think that's the best fit line. I will say when you're drawing this, make sure that you use a ruler. Here's another best fit line, and this one kind of goes through the dots that are on there, and you can see that there's one that goes, there's a dot that doesn't quite, there's a dot that doesn't quite stay on the line, and then there's two dots that don't actually go on the line, and that's okay too. Okay, but let's do stuff that's wrong. So you should say there's no title. You should tell me whoever did this didn't mark the axes. And then look at their increments. In the beginning, each line counts. So every 2 lines was 0.9. And then look, after that, every 2 lines is 1 because it goes from 0.9 to 1.9. And then it goes up to 1.1. And then it goes to 1. Like, the increments aren't the same. You can't do that. Okay, so I will take off points for that. If you're going to count off at 0.9, then the next one should have been 1.8. The next one should have been 2.7. The next one should have been 3.6. The next one should have been 4.5. The next one should have been 5.4. Okay, so you can't change your increments like that. Okay, so your job. At the bottom of page 27 is a set of data. So you're going to pause this video and you're going to answer these 2 questions. What is the independent variable and what is the dependent variable? So go back, look at the data on page 27, commit to an answer, and jot it down. Pause the video so that you have time to do that. All right, so now you're going to go back and read the paragraph right above the data table. Your answers are in there. So make sure that you have the right answers. And if you don't understand why you don't, make the correction and then just be sure to come and see me so that I can help you figure that out tomorrow. Okay? But make sure you have the right answers because it's going to mess up your graph if you're doing it wrong. All right, so here is your job. You are going to graph your data. So you might need to pause this, but you need to read so that you remember what you're supposed to do. Make sure you double check your graph. Here are 4 things that you need to make sure that you did. If you didn't do this, you need to fix it. So hit pause again and make sure that you've done all these things. Now that you have your best fit line and you think that you've done everything correctly, now we're going to use your graph to figure out the answer to this question. So you're going to write this sentence at the bottom of your graph, and then you're going to answer it. Remember I told you your best fit line may not look like anybody else's. So you may not match your answer here, and that's okay. Make sure you base it on your graph. All right, you're done. Here's what to submit.